JavaScript provides several built-in methods to transform, format, and manipulate numeric values. These methods allow for conversion between numbers and strings, control over decimal precision, formatting for scientific notation, and parsing strings to numbers. The toString method converts a number to a string. It can also convert numbers to different number systems, such as binary, octal, and hexadecimal, by specifying a radix or base. For example, the number 42 can be converted to its binary representation, 101010, using the toString method with a base of 2. Similarly, it can be converted to octal, which is 52 with a base of 8, and to hexadecimal, which is 2a with a base of 16. When using toString directly on a number, it needs to be wrapped in parentheses. The toFixed method formats a number with a specific number of digits after the decimal point, and it returns a string. For example, using toFixed with a value of 2 on the number 123.456789, we'll round it to 123.46. The toPrecision method formats a number to a specified total length, that is, significant digits, also returning a string. For example, if we use toPrecision with a value of 3, it will return 123, and a value of 6 will return 123.457. A key difference to note is that toFixed counts digits after the decimal point, while toPrecision counts total significant digits. The toExponential method formats a number in scientific notation, which is a coefficient multiplied by 10 raised to a power, with the format coefficient a plus or minus exponent. For example, 1.23 plus 2 means 1.23 times 10 to the power of 2, which equals 123. The optional parameter, fraction digits, controls the number of digits after the decimal point with a range of 0 to 20. Like other number methods, this returns a string and not a number. The parseInt method parses a string and returns an integer, while parseFloat parses a string and returns a floating point number. parseInt accepts a second argument, radix, which specifies the base of the number, ranging from 2 to 36. parseFloat always uses base 10. parseInt will return an integer, while parseFloat can handle decimal numbers. Both of these methods will ignore leading white spaces. A key point is that both will return not a number or nan, for an invalid input. It is important to handle numeric errors in JavaScript. The common numeric errors include not a number or nan, which results from invalid numeric operations or parsing failures, infinity or negative infinity, which results from division by 0 or operations exceeding number limits, and floating point precision, where JavaScript's binary floating point math can lead to precision errors. Not a number can be checked using the isNotIn method, and infinity can be handled using the isFinite method. Floating point precision errors can be handled using the toFixed method. It is best practice to use numbered isNaN instead of the global isNaN to check for finite numbers with numbered isFinite, and use toFixed for the display of decimal numbers. JavaScript provides the International Number Format object for formatting numbers for display. This provides locale-aware formatting, currency, percentage, unit, and compact notation support. For example, the number 1,234,567.89 can be formatted to currency using the ENUS locale and USD currency, resulting in $1,234,567.89. Similarly, a big number, 1,234,567, can be formatted to a compact notation, resulting in 1.2m. Percentages can be formatted, with a value of 0.1234, resulting in 12.3%. Always consider the locale when formatting numbers for international users. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.